Hey everyone, it's Coach K. Today we're going to be talking about parts of circles and different things about circles. So the first thing that we're going to be talking about is the diameter. So the line that passes through the center and has endpoints on the circle. So my diameter is right here. Then the next one says, has one endpoint on the circle or center and the other on the circle. This is called a radius. So the line right here would be the radius. Both endpoints are on the circle, does not have to go through the center. So it'd be this line right here. This is called a chord. Touches only one point on the circle. So right here would be the point it touched. It's only one point. This is called a tangent line. The last one is intersects the circle at 2 points and keeps going on each side. This is called a secant line. So if you look, these have arrows going on the end of each one of these. I am not going to go over the formulas because we really don't need them for today's lesson. All right. Okay, so we're going to talk about a tangent line. Okay, we're going to talk about a tangent line. A tangent line of a circle, if and only if it is perpendicular to the radius. So it'd be in this figure right over here. Line M is perpendicular to segment PQ. So because it's perpendicular, remember it forms a 90-degree angle right there. So now we have to say, is ST a tangent line? So if you remember that we're trying to figure out, is this a right angle or not? Okay, so remember you have three sides. If it's supposed to have a right angle, remember it's c squared, our box, a squared plus b squared. If it is equal to, then it is yes. So right here, remember our c squared is our longest side, so here's 37 squared equals 12 squared plus 35 squared. So when I combine these right here, 37 squared is 1,369. And 12 squared plus 35 squared is also 1,369. So when we put this in our box, it is equal to. So is it a tangent line? Yes. It is a tangent line. Let's look at the next one. So on this one right here, it says the diagram point B is a point of tangency. Is a point of tangency. So since it's a point of tangency, it is a 90-degree angle. Then it says find the radius. So right here, we're still going to use Pythagorean Theorem. A squared plus b squared equals c squared. We can put an equal sign there because it says that it is a point of tangency. So that gives me r squared plus 80 squared equals our whole line for our c, which is 50 plus r squared. So we can't combine anything on this side over here just yet. So let's look at this 50. So I'm going to come over here on the side. And remember, you can do double distribute or you can do the box method, whichever way that you chose to do. You can do FOIL. So I'm going to go ahead and do the box method because it's very similar to what you did in science also. So right here would be 2500. I have 50R. I also have 50R. So what I'm doing is I'm combining the two. So I'm going to take this one and this one to get that one. I'm going to take this one and this to get that one. So that's what I'm doing. So now I'm taking R times R, which is R squared. Oops. So this would be R squared. So when I combine them all, I have R squared plus, I'm going to combine these two because they have the same last name, 100R plus 2500. All right, so let's take that and bring it on over. So right now I have R squared plus 80 squared equals R squared plus 100 squared plus 2500. So subtract R squared on each side, so let's get rid of that so we will no longer have it. So 80 squared is 6400 equals 100R plus 2500. So I'm just working out like a regular problem. So I'm going to subtract 2500 and that gives me 3900 equals 100R. Divide both sides by R. R equals 39. So I figured out my radius to be 39. All right, so let's talk about external tangents. External, remember, is outside. So tangent lines. Every time that it has a tangent line, it touches the vertex or the circle in one point. So it will always be congruent because when it's a tangent line, it's always going to form a 90-degree angle. So when it right here, so that's technically what's happening. So I can actually say that SR is congruent to ST. So let's actually work it and use that information. So because it's a tangent line and it has one point of tangency on both of them, I can set both of those equal to each other. So that gives me 3x plus 4 equals 28. I'm going to subtract 4 on both sides. So that gives me 3x equals 24. I'm going to divide by 3, x equals 8. So the value of x is 8. All right, we have a central angles now. A central angle is from the center of the circle. So an angle whose vertex is on the center. So when I'm looking at this, I go A to C to B. So my central angle would be angle ACB. Then it says the sum of the central angle of the circle is 360 degrees. So that means all the way around from here all the way back would be 360 degrees. So a minor arc is less than 180 degrees. And you name a minor arc by 2 endpoints on the circle. So right here, I'm going to be focused on this arc right here. So I would name that arc RP. A major arc, when you think of minor, small, major, big, has to be greater than 180 degrees. And you name this by the end point and another point. So you have to have 3 total points to name a major arc. So if I'm going to name this right here, so I'm going to follow it all the way around. So I'm going from R, and then I got to go through at least one other point, M, P. That would be my major arc. Because it is greater than 180 degrees, you're going to have 3 letters because it's bigger. A semicircle is exactly 180 degrees. And it's 2 endpoints plus a point. So that means it has to have 3. So if I go right here, I'm going to go R to N to M. Arc R, N, M. So let's go over here to this picture right here. First thing what I know is that it says right here that it has perpendicular. So I know that this angle right here is 90 degrees and this angle right here is 90 degrees. I also know that since this is a linear pair right here, that these two angles have to add up to 180 degrees. So I know that this angle right here is 140 degrees. So remember, it's the same as the central angle. So this would be a 90 degrees, 90 degrees, 40 degrees. This would be 140 degrees. So what is A to B? So A to B right here is 90 degrees, which is a minor arc. Now, if you look at it, remember our minor arcs have to have only how many letters? 2. So I can sit back and go ahead and say that all of these are minor arcs. So let's look at the next one. The next one says A to B to C. A going to B to C. That is 180 degrees. So what is 180 degrees? It is a semicircle. All right, let's do the next one. Arc A, B to D. So I'm going to start right here. A going to B all the way through D. So on this one, I'm going to add the 90 plus the 90 plus the 40. And that gives me 220. So since it's greater than 180 degrees, this is a major arc. Now let's do the B to D. This B going to this D right here. I have 90 plus 40. And that gives me 130 degrees. All right, so let's talk about B, A to C. B going to A, going all the way around to C. So if I look at it, me personally, I know that there's 360 degrees inside of a circle. I know that what's left over is the 90, so I'm going to subtract the 90, and so that gives me 270. So this would be a major arc. All right, so let's go look at DAB, D to A to B. So it's going to be 140 plus the 90, and that gives me 230, which is a major arc. All right, let's go to A to D. A going to D, we know it's 140, which is a minor. I have next C to D, so C to D, which is right here, which is 40. We're almost done, stay with me. All right, so on this one right here, it says chords. If the chords are congruent, if the arcs are congruent, the chords are going to be congruent. If the chords are congruent, then the arcs are congruent. So I can basically say right here that AB, line segment AB, is congruent to line segment CD. Because the arcs are congruent, these two right here, that means that the chords have to be congruent from here to here. Perpendicular chords bisector. Okay, bisector means to cut in half, so these two would have to be congruent. So I can sit back and say that H to D is congruent to H to F. Then I also can say that arc G to D is congruent to arc G to F. So I can say that this right here is congruent to this right here. Because if the segments are congruent, you can also say that the sides are or arcs are going to be congruent. So if I look at the last one right here, it's equidistant. So the chords are equidistant because it's a 90-degree angle. Those two have to be congruent. So I can sit back and say that E to F is congruent to E to G. All right, so let's look at the first one. When I notice about the first one right here, it has a 90-degree angle. Which one of those does it look like? Does it look like 1, 2, or 3? 1, 2, or 3? It looks like number 2. So when I look at number 2 right here, what I'm doing is saying, okay, I know that these two are going to be congruent to each other. So it's going to be part equals part. So I can sit back and say 2x minus 4.1 equals x minus 0.5. So I'm going to bring my x's over. I'm going to bring my number over. So it gives me x equals 3.6. Now let's look at the last one. This one has a little bit more. I know that the chords, so this is, we're going to be looking at number 1 and number 3. Number 1 and number 3. It says we're trying to find the radius of the circle. I can say that these two are congruent to each other. So first thing I'm going to do is say 4x minus 5 equals x plus 4. So I'm going to subtract x on both sides. I'm going to add 5 to both sides. That gives me 3x equals 9. I'm going to divide by 3. I'm going to divide by 3. X equals 3. So when I substitute back in, this right here is going to be 7. So when I'm looking at it, I'm going to say, okay, I can make a right triangle because I'm trying to find the diameter right here. So I can make a right triangle with this information. 3 plus 4 is 7, so this is right here 7. I know that this whole line right here is 20. So what is half of 20? 10. You are correct. And then I have a 90-degree angle. So I still am going to be solving for this one right here. So when I'm looking at it, it's going to be a squared plus b squared equals c squared. So I have right here, I have 7 squared plus 10 squared equals c squared. So I have 49 plus 100. I have 149 equals c squared. The square root of that is, it's going to be 12.2. All right, sorry for the lesson being so long. Have a great day.